Hello friends, you might have done the vector differentiation. Under the vector differentiation, there is an important topic called gradient, which is mostly found in engineering mathematics and BSc students. And here I am going to explain you the practical meaning of gradient with taking some example like the water pressure example, fire example. Then after that I am going to define the gradient, and after I am going to give you the formula for gradient, and at the end of the video I am going to solve one example for you. I am going to solve one practical example and going to teach you how to exactly find the gradient if the function phi given to us. So let's start today's video to learn what is gradient. Here I got the two examples for you. In first example, in figure 1, I got a glass in which the water is present, and let us select the two layers of the water. This is the bottommost layer, call it as a layer 1, and this is another layer of water, call it as a layer 2. Now select a point at layer 1. Let us call this point as a phi of x comma y comma z. So we selected a point in the layer 1. As we know that as you go down the depth compared to layer 2, the pressure of water is not same. The pressure changes from one height to another height. The pressure changes from one depth to another depth. The point phi of xyz is called as a scalar point function. Now let us say this point is A. From point A, suppose you want to go to the layer 2. So from point A on the layer 1, you want to go to layer 2. So you can go in different paths, like you can go through path AB, you can go through the path AC, you can go through the path AY, you can go through the path AD, or you can go through the path A. So different ways, different direction you can go from layer 1 to layer 2 from the point phi of xyz. Now for understanding purpose, I have selected only three paths, that is AB, AY and AE, and on each path let us select a unit length. Let us say I select 1 centimeter of line. Similarly, along the line AY, select 1 centimeter of line. You can even select 1 meter, or you want 1 feet or any other, but you select same length on each line. Similarly, along the line AE, even you select the length of 1 centimeter or unit length. Now measure the vertical distance along each path. Let us call this as a H1, and here is the vertical distance, call it as a H2, and here is the vertical distance, call it as a H3. So we got here the three vertical distances, H1, H2 and H3. What is the observation? H2 greater than H1. Similarly, H2 greater than H3 implies H2 is largest value of H. So what is the observation? The phi of xyz is a scalar point function, and it is spreading the field. The field is spread by it. I am showing it. This is the field developed by the phi of xyz. Here entire entire space the field is spread. There is a distribution of field due to the scalar point function phi of xyz. So this is the space, and everywhere in this space the field is spread by the scalar point function. So field generated by scalar point function phi of xyz is shown by the shaded region. Now what are the observations? Observation: phi of xyz is a scalar point function and maximum change of height is observed along AY. Here I said height, but if you are dealing with electrical intensity, then we say maximum change of electric field intensity, or if it is a temperature, then we can say the maximum change of temperature is along the line AY, such that. So maximum change of height is observed along AY. That means to get largest change of height, we must go along the path AY. So we say gradient of phi of xyz is in the direction of AY. Similarly, if you talk the temperature, suppose phi of xyz is a scalar point function on the basis of temperature. So distribution of temperature is not same in this space. It changes from one direction to another direction. So the maximum change suppose occur along the line AY, then we say the gradient of phi of xyz is directed along line AY. Now define gradient, the gradient of a scalar point function. So we have to define gradient for whom? We define gradient for scalar point function. It gives the direction one should move so that get maximum change in the field of phi of xyz. The gradient of phi denoted by Nabla phi, where Nabla, this symbol is called Nabla, and Nabla is nothing but vector differential operator, where differential operator Nabla equals to vector I into, this symbol is called like this symbol is called Daba, also called as a do. So I do call it as a do, not Daba. So vector differential operator Nabla equals to vector I into dou upon dou x plus vector j dou upon dou y plus vector k dou upon dou z. Therefore, gradient phi equals to Nabla phi equals to, here bracket and outside the bracket phi, and inside the bracket vector I dou upon dou x, vector j dou upon dou y, and vector k dou upon dou z, where vector j and vector k are unit vectors along x direction, y direction and z direction respectively. So this is equals to vector I dou phi upon dou x plus vector j dou phi upon dou y and vector k dou phi upon dou z. This is equivalent to gradient phi. Now here the example, find gradient phi if phi equals to x square plus y square plus z square at point 1, 2, 3. Now step number 1. Under the step number 1, we need to find out dou phi by dou x, dou phi by dou y and dou phi by dou z. To find out dou phi by dou x, you write here dou like this, x square plus y square plus z square with respect to x. Now this is nothing but a part of partial derivatives. It is called as a partial differentiation. So when you deal with the partial differentiation, what is written here with respect to x? So we do consider only x as a variable and remaining r as a constant. That means while finding out dou by dou x, you need to consider y and z as a constant, and derivative of constant is 0. Therefore dou upon dou x of x square plus y square plus z square is 2x, and derivative of y square is 0 and derivative of z square is 0. Similarly, while finding out dou phi by dou y, that is partial derivative of x square plus y square plus z square, when you are finding out with respect to y, only y is considered as a variable, remaining r as a constant. That means while finding out dou by dou y, x square is constant, derivative of constant is 0, and derivative of y square is 2y, and z is again considered as a constant. Therefore derivative of z square with respect to y is 0. Similarly, the third one, dou phi by dou z, that is the derivative of x square plus y square plus z square with respect to z. So that is equals to derivative of x square is 0 because we are doing derivative with respect to z. It is a partial derivative. So, and derivative of y square is also 0 and derivative of z square is 2z. So step number 1 is over. To find out gradient, you require to find out step 1. Step 1, we find out dou phi by dou x, dou phi by dou y and dou phi by dou z. Now putting these values in the formula of gradient phi. Therefore, gradient of phi is nothing but vector I. The value, that is the gradient of phi, equals to I. Dou phi by dou x value 2x and j dou phi by dou y value is 2y and vector k dou phi by dou z value is 2z. Therefore, gradient phi at point 1, 2, 1, these are the given points. In place of x, write down 1 and in place of y, write down 2 and in place of z, write down 1. So that equals to 2i plus 4j and plus 2k. This is required gradient at point 1, 2, 1 equals to 2i plus 4j plus 2k. If you think this video is worthwhile for watching, then please like, share and subscribe the channel. Thanks for watching this video. Meet you again with another topic. Till then, wish you good luck. All the best.